Welcome to Brain Vision.
Conservation of energy requires that the heat current to the copper equals the sum of the heat currents to the brass and the steel ends of the rod. So we'll denote the quantities for copper using subscript 1. And we'll use subscript 2 to denote brass. And then subscript 3 is left for steel. And we'll also use T0 as the temperature of the junction. So firstly, for part A, we know that the heat currents H1 must equal to H2 plus H3. And if we use the equation that H is equal to K A delta T by L, where K is the thermal conductivity, A is the surface area of each rod, L is its thickness, and delta T is the change in temperature, we can write the equation above as follows. So we can write that K1 over L1, the thermal conductivity for copper, over the thickness of the copper end into the change in temperature, which is 100 degrees Celsius minus the temperature of the junction, T0, is equal to K2 over L2 times T0 plus K3 over L3, where K3 is the thermal conductivity for steel, over L3, which is the thickness of the steel end, also times the temperature of the junction, T0. So if we rearrange this equation, we can solve for the unknown temperature of the junction, T0, and T0 is equal to K1 over L1 all over K1 over L1 plus K2 over L2 plus K3 over L3. And all this multiplied by 100 degrees Celsius, delta T. So if we substitute our values for the thermal conductivities for copper, brass, and steel into K1, K2, and K3, and our thicknesses of each end, we get the temperature of the junction to be 78.4 degrees Celsius. Now we need to calculate the heat currents H1, H2, and H3. So if we use the equation that H is equal to K times A over L times delta T, since we now know our value for T0, and we have that delta T1 is equal to 21.6 Celsius degrees, delta T2, the change in temperature for the brass end of the metal, delta T2 is equal to delta T3, the brass and the steel ends are the same, and they have a temperature change of 78.4 0.4 Celsius degrees. Hence, since we know the thermal conductivities for copper, brass, and steel, we know the thicknesses and their exposed surface areas, we can calculate the heat currents as follows. So we get the heat currents using the equation above. Firstly, for the copper end, H1 is equal to 12.8 watts. H2 for brass is equal to 9.5 watts. And H3 for steel, we calculate to be 3.3 watts.